Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good day everyone. Inshallah, we will continue our lecture on food preservatives topic for halal food ingredient cost. So this is the table of content for our lecture today. From introduction and classification of food preservative, there are a few type of preservative that we will cover. Application and mechanism of food preservative, and also lastly halal status and current issues which are related to our topics today lah, inshallah. So by the end of this lecture, you will able to identify key classes of food preservative, explain their underlying mechanism of action, and evaluate their halal status based on source and processing, and apply suitable preservative for specific halal food product formulation. And you can also develop an understanding on how technological function of preservatives align with the halal ingredient standard, inshallah. So we will start on the introduction. Basically, food preservative is essential for maintaining safety, extending shelf life, and protecting the sensory properties of food. Meanwhile, in halal food system, preservative play a critical role not only in preventing spoilage but also in supporting compliance with halal assurance requirement. Any preservative must be evaluated based on its origin, processing aid, solvent, and risk of cross-contamination with non-halal sources lah, for sure kan. And the image shows the in Pantai Timur we call ikan bekok, or we can also call it as a ikan kering and etc. But it is a famous dish lah in Pantai Timur, where it also implement the element of food preservative by using salt and some other preservative. So the classification of food preservative, it can be divided into 5 at least. First, for antimicrobial that inhibit microbial growth. Secondly, antioxidant that prevent oxidation. Anti-enzymatic agent that reduce the enzymatic spoilage. Natural preservative derived from the biological resources, and traditional chemical preservative. So you can after this you can differentiate the preservative. First, on the microbiological preservative. So it is function by inhibiting the growth of bacteria, yeast, and molds, and any microorganism lah. Common example include sorbates, benzoate, propionates, and bacteriocin such as niacin and natamycin. This compound are widely used in beverages, fermented food, dairy product, and also bakery items. The effectiveness depends on factors such as pH, water activity, and food composition. In other words, a fluctuation of pH can affect the functionality of the antimicrobial preservative lah. This is some example of contaminated product which probably they are preservative or antimicrobial preservative, but it is not well function in the food product. This is the coagulated milk, and on the bottom one is the botulism in the canned food, either due to preservative or maybe due to the processing failure lah. Next, it is differ in their mechanism and application. For example, potassium sorbate inhibit molds and yeast by damaging cell membrane, and is commonly used in cheese and bakery item. This is example of cheese. Sodium benzoate suppress microbiological metabolism in acidic food, and it's widely used in soft drink and pickle products. So basically, if you are developing a acidic drink, you will use sodium benzoate for your product. Next, sodium propionate target mold growth in bread by interfering with the key metabolytic enzymes. Niacin is a natural bacteriocin forms pore in the cell membrane of gram-positive bacteria, and is used in dairy or canned product. You can read more on niacin in this link in previous slide. Next, antimicrobial preservative can be visualized by protective barrier that prevent microbial intrusion. They function like a security guard that block microorganisms from entering or multiplying in the food product, or like a roadblock that disrupt essential metabolic pathways required for microbial survival. So that's how the microbial preservative works. In other case, they act as a molecular locks that disable key enzyme in microbial cells. So this is some a literature on the bacteriocin as antimicrobial and preservative agent in food. Bacteriocin are defined as bioactive bacteria peptides or protein that are ribosomally synthesized and exhibit antimicrobial activity against other bacteria. Includes strain or of closely related species. They are produced by gram-positive and gram-negative bacteria and are controlled by genes that also confers resistance to the bacteriocin produced. This is the cycle. For example, on the bacteriocin, by ribosomally produce proteaceous substances and then undergo biosynthesis, purification, and then characterization. It can work as a preservative agent, or in other words, antimicrobial agent in the food application, such as cereal-based, fruit and vegetable, dairy-based, meat and fish product. It can destroy this kind of microorganism which lead to the food contamination. That's how it works as a food preservative. You can read more in this journal related to bacteriocin. We move on to the next preservative on antioxidant. Antioxidant preservative prevent the deterioration of fats and oil by inhibiting lipid oxidation and process responsible for rancidity and off flavor. In some cases, in our cooking oil, for example, they are using antioxidant as a preservative in the oil. Meanwhile, for our chicken dish here, a snack, they are using also antioxidant to reduce the rancidity or to prevent the rancidity and off flavor. Synthetic antioxidants such as BHA, BHT, TBHQ provide strong protective effect, while natural antioxidants like tocopherol, ascorbic acid, and rosemary extract or any plant extract offer clean label alternative but we can regarding the synthetic antioxidant, we also need to aware on the side effect, the negative effect of the synthetic antioxidant their selection depend on food composition, regulatory limit, and consumer expectation for sure. So basically, different product will need different kind of antioxidant. It works through several mechanisms, including scavenging free radical, chelating pro-oxidant metal ions, and interrupting the chain reaction that drive lipid oxidation. By stabilizing reactive molecule, antioxidant extend the shelf life of high-fat foods, prevent color degradation, and preserve desirable aroma. This is the example of oil, mixture of oil, which has the contain permitted antioxidant. You can check this INS number. Basically, it's a vitamin A, vitamin D, and etc. Next, how do contaminant antioxidant work? Basically, it is related to the free radical damages cell. So antioxidant neutralizing a free radical that contained in the cell. That's how it works. Then this literature entitled Antioxidant and Antimicrobial Preservative Properties, Mechanism of Action and Application in Food. It is a literature review paper. How antimicrobial and antioxidant work in the cell of food. We may take some example in this area. Destruction of selective membrane permeability and leakage of the cell component using the weak organic acid, lactoferrin, chitosan, and etc. And then it also destabilization of protein motif forces, collapse of proton gradient, and depletion of ATP using nitrate or nitrite, such as in meat, weak organic acid, essential oil, etc. Inhibition of oxidative phosphorylation and oxygen uptake by using nitrate and nitrite, and etc. So this is the summary of how the antimicrobial and antioxidant works in the cell of food. So that's how, based on this mechanism, you can design your antimicrobial or antioxidant to be included in your food preservative based on your current requirement. Next, we move on to the anti-enzymatic agent. Anti-enzymatic preservative inhibit or slow down enzymatic reaction, such as enzymatic browning This is example of enzymatic browning in apple. Compound like sulfate, ascorbic acid, and citric acid act by reducing quinones, chelating matter required by enzyme, or altering the pH condition. That's why for us to preserve this kind of apple, we need to put some enzymatic agent by altering the pH condition. Physical treatment such as blanching can also deactivate enzyme responsible for deterioration in fruit and vegetable. In this example, in this apple juice, they are using citric acid as mentioned in the writings, for the enzymatic agent to preserve the color of the apple juice lah. Besides, they also use vitamin C, citric acid and vitamin C to preserve the color and the flavor. Next, natural preservative. It is different from the next point. Natural preservative include plant-derived essential oil and phenolic compound, microbial and derived bacteriocin such as niacin, and animal-derived compound like lysosome. This ingredient align with the clean label trend but vary in stability, cost, and regulatory consideration. Their halal status depend on source verification, extraction method, and also absence of non-halal solvent lah. This is example of lysosome chloride. So it is some of powder, macam garam lah, like salt. We know on niacin, where niacin is used, it is used in dairy products such as cheese, yogurt, processed meat, canned or packaged food, and also beverage and fermented product lah. So currently the trend for natural preservative is keep increasing due to the nature source lah basically. Lastly, on the lysosome. Lysosome is part of natural preservative. This is the article: lysosome characteristic, mechanism of action, and technological application on the control of pathogenic microorganism. That how lysosome react in food. It react, or the name is Moraminides, sourced from egg, from plant, and even from the microorganism lah. The application is in agri-food industry, drug delivery and therapeutic, biosensing, bioimaging, biocatalysis, and bioenergy. So it is a natural antibiotic, potent allergen and disease biomarker, antimicrobial in agri-food industry and veterinary, model in pharmaceutical application. It is first enzyme to have 3D structure solved, model for enzyme catalyst, protein structure and aggregation, model for macromolecule interaction and functionality, and it is a lysosome-based composite lah. So this kind of preservative is also in trend lah in the food industry nowadays. Lastly, on the traditional chemical preservative, we use this kind of preservative in our house, such as salt, sugar, vinegar, lactic acid, nitrate have been long used to inhibit spoilage in meat, pickle, and fermented food. This preservative work by controlling water activity, lowering pH, or interfering with the microbial metabolism. They remain widely used due to their affordability, reliability, and regulatory acceptance. For example, in this Pak Ali jeruk Pak Ali, and this salted egg, and this kimchi, all of these are using traditional chemical preservative lah. So basically, if it is used as a standalone preservative, the shelf life not be so long lah compared to the synthetic preservative. So we move on to the application of food preservative in food product. So basically, these are some example that is commonly used. In meat product, they use nitrite and lactates to inhibit the pathogen in this meat product. Secondly, in the beverage, they rely on sorbate and benzoate due to the low pH of the water. Basically, the water is acidic. Fruit and vegetable product are often require ascorbic acid or citric acid, especially on the fruit juices. And then oil and fats rely on tocopherol and synthetic antioxidant such as vitamin and etc. Bakery product commonly use propionics and sorbates to control the mold growth, and even it can affect the texture of the bakery products lah. We take some example: halal beef sausage. In halal beef sausage formulation, sodium nitrite is used within the limited regulation to control the Clostridium botulinum and maintaining cured color meat. Other than that, the Clostridium botulinum is controlled by the cooking process lah, processing. Based on food regulation, this is the permitted preservative for meat product lah basically. So the lactate serve as multifunctional antimicrobial that also contribute to flavor and maintain moisture retention. Ascorbic acid support color stability and reduce residual nitrite level. Even nitrite can also preserve the color of the sausage. Each ingredient must be evaluated for halal origin and compliance with the halal standard lah. In fact, for us to determine the halal status of the preservative, even preservative itself is the critical control lah, halal critical point for determining the status of the halal product lah. Next, halal assessment framework related to the preservative. Evaluating halal status require a structured assessment of preservative sources, including whether the material is derived from plant, microbial, or animal origin. Additional factors include processing aids such as enzyme and type of extraction, solvent use, possible fermentation media, component, and presence of anti-caking agent or carriers. Each step must be verified to ensure halal integrity across the supply chain. So basically, most of our preservative nowadays come from different type of sources lah. For example, plant, microbes, and animal. You also know that if it is from plant, we must also consider the extraction process. Is it using the permitted or halal ingredient or not? For example, in the making chocolate, the critical part in here is maybe during the fermentation. Is it mixed with any non-halal ingredient, or even roasting? Is it mixed with the non-halal ingredient? And so many, even if we call it as it is just a chocolate, but we have to ensure that during along the process, the ingredient used is halal. This is some example on the cheese part. For example, in cheese, for sure we concern on the rennet, but there are also use of before it is making into a cheese, they probably use preservative, maybe non-halal preservative to preserve the cheese. So halal status by category, basically for synthetic, generally halal because they are chemically synthesized, although carriers still require verification. The carriers, for example, on the extract status, on the encapsulation, and etc., we have to check to verify the status. On the if it is from the natural plant, it may be extracted using ethanol or even any non-halal chemical. So same goes to synthetic. We have to verify the process lah. On the microbes, Schizacynamycin require confirmation on halal growth media. We also one critical part on halal industry, especially on microbes. The growth media is made from non-halal, so we have to ensure that, or as a food, as a scientist, we have to develop something halal growth media lah. And lastly, on animal derived such as lysosome, if it is from eggs, should be no problem lah, it's halal lah. Meanwhile, for example, collagen based ingredient, it require halal slaughter verification. Or even animal derived is also a critical halal point, so where we have to verify the status of the animal itself lah. Next, some issue in 2014, penjelasan kod E or E code, or currently we are using INS number lah, yang dikaitkan mengandungi lemak babi. In 2014, there are viral issue on the chocolate where the netizen they viral about the E number code that is stated in the food ingredient. They say that all E number are made from porcine. So Jakim need to do something lah kan. So code E is for bahan tambahan additive for additive food lah. Hanya selalu digunakan pada label makanan di negara EU lah, Kesatuan Eropah. Bahan aditif ialah bahan yang selamat dimakan dan ditambah secara sengaja ke dalam makanan dalam kuantiti yang sedikit bagi mempengaruhi kualiti, penyimpanan, pemprosesan, penyediaan dan pembungkusan makanan. So E number is not related to halal lah in general. Meanwhile, skim penomboran ini mengikut sistem penomboran antarabangsa, International Number System ataupun alias INS lah. Currently in food regulation, we have to state the INS, not E more lah. So this statement is released in 2014 kan. Yang telah ditentukan oleh jawatan kuasa Codex Alimentarius. Ia adalah koleksi pelbagai standard, kod praktis, panduan antarabangsa yang diiktiraf berkaitan dengan makanan, pemprosesan makanan, keselamatan makanan, bertujuan untuk menjaga kesihatan manusia dan memastikan kod perdagangan yang beretika dijalankan. So basically, INS number is for the product to be exported to EU, you have to follow their regulation also kan. So in general, tidak semua nombor E yang digunakan untuk membuat sesuatu produk makanan berasaskan dari sumber yang haram. Bahan-bahan aditif ini boleh bersumber tumbuhan, sintetik, mikrob, semula jadi, kimia dan juga haiwan. So sehubungan itu, sekiranya produk tersebut merupakan produk tempatan dan mendapat sijil pengesahan halal Malaysia, maka ia boleh digunakan tanpa was-was sekalipun mempunyai kod E. Tetapi sekiranya produk tersebut bukan produk tempatan serta tidak mendapat sijil pengesahan halal Malaysia, walaupun menggunakan kod E yang sama, kod yang sama, pengguna dinasihatkan agar berhati-hati dalam memilih produk tersebut. So in general, different code number will have different type of additive lah, colouring, preservative, antioxidant, pemekat, pelembab, stabilizer, emulsifier, and etc. Same goes with INS number lah. So in general, E number or INS number has no issue with the haram test status. First thing first, we have to verify the CJ halal lah kan. And secondly, the E number or INS number cannot verify the halalness of our product lah. So we have to check in detail the list. For example, is it the colouring, is it from the carmine? As I mentioned before, carmine is haram kan. So we have to double check, cross check with the data and the current fatwa status in our country lah. So it's some issue related to food preservative lah kan. Next, contemporary issue. Current challenging issues related include the growing demand for clean label halal product that avoid synthetic additive. So our consumer nowadays are concerned on the synthetic additive lah. They don't want to consume synthetic additive. They said that it can cause hypersensitivity, cancer, and etc. The need for halal certified natural preservative. So we have to find alternative for the preservative lah. And variability in essential oil composition, for example. So these are three most common used chemical or preservative in our food nowadays: benzoate, nitrite, and sulfate lah. And don't worry, this three is allowed by food regulation, but the side effect is arguable lah among consumer lah kan. Advances in biopreservation such as lactic acid bacteria cultured on halal plant-based media offer new opportunities. Emerging technologies including nanotechnology based encapsulated preservative and AI-driven shelf life prediction aim to reduce additive dependency lah. So we hope that in future we don't have to too dependent on the synthetic or chemical preservative lah. First, secondly, we also need to for us to develop the natural preservative, we need a good media lah. For example, halal plant-based media, because as I said before, most of media in the current market are using the non-halal sources lah. So as a Muslim, it is our opportunity to contribute in developing new plant-based media for halal purpose lah kan. Next, on the regulatory snapshot, preservative must comply with national and international regulation. For national, such as Food Act and Regulation. For international, such as Codex Alimentarius. And then halal compliance must follow halal JAKIM halal certified guideline. And in our country, we are using the MHMS, MPPHM, and MHMS, Manual Procedure Persejilah Halal JAKIM Malaysia. And also we also need to follow the MS 1500 2019. So that are our main references lah, three document. Codex Alimentarius for global references, and understanding this framework ensure product are both halal and also safe. As a summary, food preservative play essential role in ensuring safety, stability, and quality while supporting halal compliance. And their classification into antimicrobial, antioxidant, anti-enzymatic, natural, and traditional chemical categories help clarify mechanism and application, because different type of preservative will have different mechanism and application in our food lah. A clear understanding of halal sourcing, processing, and regulatory standard is crucial in selecting suitable preservative for halal product formulation. Maybe this knowledge, this basic knowledge, will get you query on exploring the potential preservative that you will use in your food product development soon lah, insyaAllah kan. So there are some activities that I provide in the clip. So you have to choose a food product. You can snap picture, and you can find this product either in supermarket, etc. And I want you to identify 2 appropriate halal certified preservative in the label lah kan. And then justify your choice based on the functional role, mechanism of action, halal status, and regulatory limit lah. The first thing first, maybe you can based on the ingredient, you can describe the function of the preservative for antimicrobes ke, antioxidant, and etc. And lastly, thank you so much for your attention. That's the end of our topic. I have prepared you a quiz to test your understanding, and you can scan this QR code or fill in the and submit the quiz in the Google form lah. Thank you so much for your attention. Assalamualaikum warahmatullahi wabarakatuh.